Over here in this question, first of all we have to understand what question is demanding from us. In this question, you know that the mass is given, so the given data will be first is given data, and the given data is, first of all we have mass of the object, it is artificial satellite, and it equals to 537 gram. We can convert it into kilogram. It will be 0.537 gram. And no, it is in kilogram as well. It is already in kilogram. It is already in kilogram. So 537 kilogram, and then the radius is given here. It is equals to 2.5 into 10 raised to 7. And what is the gravity of the, because acceleration equals to gravity for an orbiting satellites, and up to this point we already know that mg is equal to m over r square. And when it equals, we can cancel this m over here. So for value of gravity, what we can do, we can simply put the values of g, m and r square, and we will get the value of gravity, which will be the acceleration which was demanded in the part A of this question. So the value of g is 6.67 multiplied by 10 raised to power minus 11, and its unit is Newton meter square by kilogram square. Then we have to put the mass of the earth, because the capital M is over here, so M equals to 5.98 multiplied by 10 raised to power 24 kilogram. Then we have to divide it with r square, and which is given, the value of r which is given is 2.5 times 10 raised to 7 by taking it square, and it is, the value of r is in meter. So this will convert into meter square, and we can cancel this meter. This kg can be cancelled with this square of this kg, and with what value we will get by solving this onto scientific calculator. I am just solving it right now. It will give us approximately 0.64, and it will be Newton per kilogram. And you can also convert this into the SI unit, Newton per kilogram. What is the value of Newton? It is kilogram meter per second square. So dividing it with kilogram cancels this kilogram, and we got g is equal to 0.64 meter per second square. So this is value of acceleration, the part A. For part B, we can simply apply F is equal to ma, or we can apply F is equal to mg. Then we can multiply this value 0.64 into what was the mass? It was 537. You can multiply it with 537 and we will get 340, and the value of force will be Newton. Or you can also execute the full formula, for example G m over r square. You can put the value of the mass of Earth, gravitation constant, then radius which is given, and then mass as 357, and then you can find this value as well. So it depends upon the given data, because we have done it part A, in which we got the acceleration, so we do not need to solve this again. We can simply multiply it with the given mass. So you got up to this point? Okay, so this homework is done. Now we are moving to the second homework. Let me paste questions over here for the second homework, and then we are going to solve that one. As I have pasted this homework, you can read question number 1. An astronomer determined that okay, so the distance which is given over here is this one. It is r, and traveling speed over here is this one. It is v. As we know, we can, for the velocity of the objects orbiting, we have a formula which is v is equal to under root g m over r, and the given data is r is equals to 5.34 multiplied by 10 is to 17, and v is equal to 7.5 multiplied by 10 is to power 5. So these are the values which we have, and we can simply sub these values and get the result. And the only thing which we have to do is to rearrange this for mass, because m is what we have to find. So let me rearrange it, and then I will put the values into this formula. It will be v square is equal to g m over r, and r will be equal to r v square by g will be equal to m, and we can now put the values for r, v square and g. So what is the value of r? Is 5.34 multiplied by 10 is to the power 17. v is 7.5 times 10 is to the power 5 square, and g is already, we know that it is gravitational constant, to 6.67 multiplied by 10 is to the power minus 11. So doing this, we got m is equal to 4.5 multiplied by 10 raised to the power 39, and we know that mass will be in kilogram. Also you can solve the units. For example, the unit of radius is meter and unit of velocity is meter per second, and then the unit of gravitational constant is kilogram meter per second square. Then because it is Newton is equal to kilogram meter per second square, and then meter square by kilogram square. So working out with this, so m square and because we are going to take square of this one, so m square will be cancelled with this one, m will be cancelled with this one, kilogram will be cancelled with the square, second square will be cancelled with this second square, so only kilogram is left, which is that one. So bringing it up, we will get kg as a unit. So if we apply the unit conversion, it is also valid, but we already know the unit of mass is kilogram, so we do not need to. And this is for question number 1. Now these other questions which we have to do are 2 and 4. Okay, in the second question, so in the second question, sun in a near circular orbit radius. Okay, so radius is given, the radius of Mars is given as well, radius of Mars. Okay, so the force is also given, the which Mars is experiencing. Calculate speed of Mars and the period of revolution of Mars in terms of Earth. Okay, so first what we have to do is we have to write the given data. We know that the gravitational constant is 6.67 to 10 to the minus 11, and we also know that mass of sun is 2 into 10 to the 30. So and other given data is already underlined, so I am going directly for the solution of this question. The first formula which we are going to use is the same one. V is equal to under root G m over R, and then we know that T is equal to 2 pi R over V. Actually V is equal to 2 pi R over T, but we kind of rearrange it for the time period, and that's it. We have to just sub the values and get our answer. And V is equal to 6.67 multiplied by minus 11. Then the mass of sun is 2 multiplied by 10 to the power 30 divided by 2.28. This is the one which is given, 2.28 multiplied by 10 to the power 11. And then we can simply get this value of speed, which will be, let me solve it on the calculator. Okay, it will be 2.41 times 10 to the power, I am rounding this value, it is 2.4128, but I am rounding it up to two significant figures. Okay, for three significant figures, 10 to the 4 meter per second. So this is value of velocity which we need to get, and then You have to find the velocity time period. Okay. So time period is equals to 2 pi r over v. Now we have value of 2 pi 3.1416 and r is 2.28 multiplied 10 raised to power 11 divided by velocity is 2.4128 into 10 raised to power 4. Okay, I will get value in terms of second and then I need to convert into years, but first of all let me solve this one. Okay, this will be 5.937 multiplied 10 raised to power 7. Okay, then for it is in second, then for converting it into year, this is also asked in the question. Into for in 1 year there are 365 days, 24 hours and 60 minutes. So it will be 1 minute by 60 seconds. So it will cancel this second. It is converted into minute. So 1 hour divided by 60 minutes. It will cancel the minute and it is converted into hour. Multiply by 1 day by 24 hours. So it is converted into days. As there are 365 days in a 1 year, so 1 year divided by 365 days, so it is converted into years. So dividing it by 60 times 60 times 24 times 365 will give us, okay, we are going to use 3 significant figures. It will be 1.90 years. So that is the time period. You got it? Okay, if there is any confusion you can ask. Now moving to the last question for today homework which we have is question number 4. Okay. Okay, see, satellites can orbit the moon very close to the moon surface because the moon has no atmosphere and there is no air resistance. Okay, so 75 minutes. Okay, we also need radius and mass of the moon for given data. Okay, let me solve this one. First of all, given data, what values we have. Okay, so radius of moon is 1.74 times 10 raised to power 6. You have to memorize this as well because this may not be given in the question. And the given distance d is equal to 25 meter. Mass of the moon is 7.36 times 10 raised to power 22. Okay, so because we have formula which is equal to V is equal to under root G m over r, and right now we have r is equal to r moon plus distance d. And then we have to sub the values. V is equal to under root gm over r plus r moon plus distance d. So what we have, 6.67 into 10 to the power minus 11, and mass of the moon 7.36 into 10 to the power 22 divided by 1.74 into 10 to the power 6 plus 25. So we will have 1.7 taking its under root into 10 to the power 3 meter per second. Okay, you got this one as well. Actually 725 meter, adding 25 meter into 1.74 into 10 to the power 6 meter does not make any sense, because it will be a very minute value compared to the radius of moon. So it is approximately the same. It will be 1.74000 and then 24. So because we are not working with that much significant figures, that or that much least count, that is why we can simply ignore this one, or you can put it in calculator and you will get the same result even if you add 25 or even if you do not add 25. You got it?